Hello, everybody. It's so nice to see you all. Bright and early, thank you for coming. I'm Priyanka, and this is Mario. And we work at a company called Thiink, which is in the energy management space. In the past, I ran the Cloud Native Computing Foundation, CNCF, the home of Kubernetes. That was the last cool thing before this cool thing. And, you know, in the 10 years I was involved with Cloud Native, I saw the same twists and turns with enterprise adoption in the Kubernetes landscape as we're already starting to see in this new world of generative AI. For the past 6+ months, I have been vibe coding using generative AI to build, and I'm really excited to share my perspective of the experience, the similarities with the past, and where the deja vu comes from with you.
So, my name is Mario. I come from a telco and IoT background. 2022, I started coding Energy OS, it was called, where we created a platform that was enabled for LLMs to execute on. So back then, I saw that. And the epiphany was 2021 when I tried out GitHub Copilot. I don't know if you remember that back in those days, tab completion. And I realized within 5 to 10 years, 80% of the simple code will be done by AI. That's a given. And we're here now. We surely can do that within Thiink to do the simplest tasks. That's 100%, I would say.
Right. So at Thiink, we power over 10,000 buildings, both commercial and residential, in their various needs of power. And so some parts of our technology are critical infrastructure.
Yeah, I should be coding now since, since it's so, yeah.
Well, okay, Mario, do you think you'll feel better if you just set off a process and something started getting built? Okay, all right, I just took the liberty of pulling up your to-do list for you. And so if you want to go ahead and set something off, feel free.
Yeah, absolutely. So what I have to explain first is that, so you get accustomed to it. I will go through this during the presentation, but I need to kick it off because it will take some time. It's an autonomous flow that do gating and fork out lots of agents. But what we do, basically, we have PRDs that break down the features break down into tasks, and those tasks we can implement in waves in parallel, depending on the dependency graph. And we're going to kick off one of the implementation that hopefully creates freeways. I don't know, because it's an LLM, it might even shop it another way, but hopefully it does that.
All right.
So, can you see my screen? Yeah. So I kick up Copilot. We're using the Copilot CLI. I run it in autopilot so it doesn't get stop. Allow all. So let's see, think of this stats. So what we have in our repo, we have all this information, so we have a custom command that we can list all the status of them. So let's, I have a sheet one there. So we use a skill called implement feature, that's the orchestrator that forks out and uses this excellent task scheduler in this Copilot. So you can actually schedule sub-agents that can schedule other sub-agents to handle the context really, really well. So let's fire it up. Hopefully, because we have got lots of timeouts since build started, it will finish up. I have a backup if it doesn't. So, but what it will do now, it will read up the context. It's immutable, everything. So it will read back, see which tasks belongs to this feature, what PRD it belongs to, and so and read up the architecture, and then start to create a plan for the implementation. And switch over.
All right. So, do you feel a little better now?
Yeah, nervous. But better.
Awesome, awesome. You know, we weren't always this comfortable with AI-enabled workflows. It all started in 2025, really, in earnest in Thiink, when the CEO, just like I think many other CEOs out there, made the mandate that we should all try to use AI-enabled tools to help us do our work bigger, better, faster. Unlike most other CEOs, though, our CEO was utilizing these tools himself and had a little bit more credibility than normal about what was working, what was not working, and he truly saw the potential. At the same time, we as the team, though, were not so stoked. You know, as I said before, 10,000 plus buildings are relying on Thiink for critical infrastructure, such as heating, ventilation, and the orchestration for that. You don't really want to be the cause that a pensioner in northern Sweden didn't get heat and then had health problems or worse.
So, it can be really, really cold. We have, where I come from, is near the polar circle. We have minus 40 degrees in the winter, Celsius.
Yep.
So, yeah.
And we're deployed in places like that, so that tells you something. But we gave it a go with caution. At first, you know, our efforts were more POCs that were glitchy. I personally felt like I was wrestling hard with the early models, cloud models of Sonnet and then Opus to build a new website for Thiink. It was tough work in the beginning. I felt we were fighting every day. Fast forward to February 2026, and I had this major wow moment. For me, it was with the release of Claude Opus 4.6. I remember actually messaging our CEO being like, I just built this section in 5 minutes. This is crazy. And it was so exciting. I even remember thinking that I would think of that moment in the future. I know for Mario, he has a different experience with 4.6. He has his own favorite model story he will tell you in a minute. But we got really started and started seeing some good wins. And we have all areas of business were impacted. So our CEO and controller in the business, they created a Claude-based request for quotes workflow, which is basically how it's like an RFP process to apply for commercial buildings installation and electrical projects, et cetera. And instead of days, it was taking minutes. Now keep in mind, each application is worth between $100,000 and $800,000. So this is really meaningful. Even in the teams, like our head of product experience, she has now been prototyping and building features from zero to really like working options in days. For example, meet 𝗬𝗲𝗀𝗀𝗀𝗀, who is a chat agent that she's built to talk about what's going on. And she has a technical background. She's an engineer by training, but in the past, having leaned more into product, she would have felt a little reticent to take this on, but here with her guidance, Codex did a lot of work, and here we are. I myself have become the one-person MarTech team for Thiink, where I'm building the company website in-house with all the CMS, CRM attached, all of that. In Claude's completely unbiased and never flattering me view, I'm saving us about between $120,000 and $200,000 a year. But you know, this slide, it behooves me to point out, is also a bit of a double-edged sword. You see here, I'm showing you screenshots and not the actual site. So in our business, we don't use this particular site for like lead gen and those kinds of business needs. So I had a bit of a leeway to make this as beautiful as I wanted. And so here we are, 6 iterations later, and I really need to ship it. So generative AI is enabling my OCD a little too much. But on the other hand, you see those case studies and news, like this would have taken me weeks to build with like all the permissions and stuff. And this was 2 days with final approvals. So it's pretty cool. Mario says that on the engineering side, the 10x return comes where the engineers are weakest. And like someone who is not security-minded will suddenly have better security posture in their PRs. He himself is a perfect case in point. If I'm not wrong, Mario identifies as a backend engineer. And he, as you see in his GitHub repo, he says, here's an ugly mock. Now, sure, this is not a Picasso, but this is fully functional and gonna do the job. This is a great UI to start from, and this is generative AI enabling Mario. So clearly, Thiink was seeing lots of wins in different parts of the business. You know, we were really having what can be described as a good time. What could possibly go wrong? Well, so this is where we come to new tech, old problems. On April 19th, 2026, Anthropic banned our organization. All our AI-enabled processes came to a halt that were related to Claude anyway. We made a business decision that all the business processes, such as the RFQ work, even my front-end stuff, we would gonna wait to figure out till things got sorted, and the core engineering could continue through another backup tooling such as Cursor. Because then we had to make that decision because in the other tool there is a markup on tokens and that costs money. Being a bootstrap startup, you have to evaluate your choices. So it was a dark time, which was very demoralizing for this team that had suddenly become this group of builders. And I'm happy to say, 10 days later, we resolved things, we're back in business. But even as we did that, we've had glitches to solve on the billing, payments, all that side, reminding me of what is the famous thing that we've been dealing with in cloud native, FinOps. So really, this has been a very deja vu experience for me. What are we dealing with here? Vendor lock-in, lack of data and workflow portability, a FinOps nightmare. This is, I mean, we just got into this new era and we're talking about all the things from the old era. So this, in some way, actually also gives comfort because, okay, we've done this before, we figured it out, we'll figure it out again. The big learnings we had as a team were, if you're working in-app, like if you're in the Claude app or ChatGPT app for something and have built a process there, there is no real portability available in those, and things can be truly lost. You'll get your data back one day, but you can really be stuck. Anything that relies on implicit memory or a specific chat window. So for example, I built an agent to help me with the copywriting for the website and had all these tone of voice, product marketing, and this and that. And with the 1 million context window, I was really having a good conversation about which direction we want to take. And then suddenly it's gone. So I had a lot of friction just internally, moving to a different tool. Any tool, realistically, that adds a markup is not a good backup, because if you have any financial responsibility in the company, you'll end up having to make choices when you've gone dark with one vendor, and not everything can go because the markups are pretty high. And this is the most important one. Brilliant colleagues, whether they're human or machine, can quit at any time, and you have to prepare accordingly. One of the reasons generative AI really took off in Thiink is because we had so much fun building with it. Here was this really smart person that was always available, ready to talk about my ideas and go. And then suddenly, they've gone dark. This has happened before in human scenarios. It can happen in AI scenarios too. So that's my story. Mario, do you want to tell yours?
Yeah, let's do that.
I'll switch over.
I will quickly show you that it is still implementing, has some problems with the TTI. Let's see if it solves it. But it's done its smoke test and so on. Yeah, so the story is old as software. The drift. We all have it because we have an internalized view of how a function behaves or what a word means and so on. And we spend a lot of time syncing this in architectures, design, meetings, and code reviews. So we review each other to sync this. And that works pretty well, lots of job to do. But LLM is not any different than a human. It has chewed a lot of data on the internet and got some form of internalized view of everything. And we need to sync that to it as well. But it has a bit more limited context and attention span, but the thing that it does most is that it can chew so much data and spit out so much code in a so short period of time, and it has an excellent way of writing self-confident code that are not correct by your standards. And it can even invent stuff from thin air. So the drift is real, and we need to harness it in some way. Because the consequences is that the code base will rot. You will have starting to have slight differences. You have the same different words for the same thing, and then when we start to reason about it, or the LLM in our case, because we're auto-coding everything, it starts to interpolate the code wrong and do even more wrong. And since it's so fast, it will go really fast in that way. The bug frequency goes out of the roof. I saw an investigation of that teams that uses AI for coding for 50% or more, the bug frequency goes up 53%. And one big thing is that they haven't harnessed it, so try to create the correct code. Yeah, so non-invest, and it becomes very expensive to maintain. The thing that should accelerate us will decelerate us. So vibe coding, I think, is really good because you can get your prototypes and everything and ready in time. But if you're going to have a product that's going to ship next year and the next year after that, then the problem will start piling up. So enter the Thiink harness. So yeah, we have to do as we always have done, do the spec, do the design, do the architecture, and make sure to communicate that properly to the context, because it's all about context management here. What we started with was we used ChatGPT to do our research back in the days, and iterate our designs. They have really small context window, so we tried to tell it what to do, and it derailed directly, and it was hard to get any usable code. Test code, yeah, could do. Documentation, okay, but when Claude 4.1 came, yeah, now we can start doing this, audit the test, but fix small fixes and then documentation. But we realized we have a lot of products. We have different types of languages and somewhat different architecture. Quite sound, of course, as every big, when it's million+ lines of code, you have better and worse parts. But most of it is quite good. But we are we discovered that we need to have a way to express our architecture that don't make the LLM derail so easily. So we have used some parts of domain-driven design. We have done some parts of clean arc and hexagonal and so on. But now we restated our purpose and restated our architectural and design principles, so we can make it our system much easier to interpret. So we even did scaffolding, so it will be easy for the AI to understand. Oh, I go to ports to examine an interface. I go to adapters to see which are the implementation and the domain context and so on. So that was our first discovery. The second one was Claude 4.5, because we didn't like 4.6 so good. I don't know if you remember this, but it stopped adhering to instructions that well. Things that worked really well in 4.5 started, I do whatever I like, and then they override the system prompt for that. So 4.7, thankfully, was the patch for that one. But 4.5, now it really could code. We can have two different services that we are going to join and do some data. Previously, that would be crap. but now it actually could code and do understand those two services. Sorry, I got cough. So we wrote a lot of skills, a lot of specialized agents, so security auditor, resilience auditor, different experts, API experts, and so on. Earlier, the context we had was too small to really explain what we want to do. Now, our context was too large, because now we're trying to pack everything into the context. And what should it pay attention because LLM is an attention mechanism in the end. That's the transformer architecture. So, and then we realized that we need to pack in information that it should be guided by, and then what should it pay really much attention to. So we don't have must in everything and must not. We have a few of those, so it really paid attention to that. So, and a continuation then, we started to continue develop this, and we will develop this in the future for as long as we develop our software. But it's a better harness. So we started to think that, okay, let's put our information into the repository in a more machine interpretable way. You can RAG, of course, but RAG is more, oh, I can take this and this and this, because you use a vector similarity to find the text. And you can do clever things. So you can use a graph database with RAG, and there's lots of job with that as well. So let's stick to good old strict traditions to define our specs and make it, just adjust it a bit so the LLMs can easily chew it and put it into their contexts. We have a product owner in our company. He is awesome. He knows everything about our business. He knows the customers really well. He has constant contact with them, and he knows technology okay. And what he does, it's chaos engineering, so he is really creative. So lots of Google Docs. We have mocks that he does with Claude to try to visualize concepts that he wants to have implemented and put those into roadmap items with slap it into a few goals and some use cases. And then we will have to break this down. And what we do now is that we use a skill to break those down into PRDs, so we define those scopes. And then we take those PRDs, take one of them, and use our tech skill. And that tech skill, it automatically breaks those down into that skill features that we can parallelize. Sorry, I'm a bit nervous. Tech feature, it's called. Parallelize. And it uses several sub-agents depending on what the PRD is about, what we're supposed to do in this feature, and writes one first. But it is a human in the flow, workflow. So I, as an engineer, steer it and say, okay, but you got this wrong, you should partition this way, we need to do this, have you thought about that? And it reiterates from the older iteration, the instructions, and see, okay, I need help with security and resilience because I didn't cover that good enough, or it figured it out. And then when it's done, we have a feature draft. After the feature draft, then the Socratic method, yeah. So Matt Peacock's excellent Grill Me. If you haven't tried it out, try it. It's awesome. It's a few lines of code. So, but it's a Socratic method, and so heavily inspired by that, we use our context, read it in, grill the user on our common terms, ubiquitous in the DDD world. Is there any architectural changes that we need to do, and so on. And I have to answer every question. It forks out sub-agents to perform more grilling in specific areas, and we're very keen on security, so often it forks out the security agent for that. When we're done, we have written a brief. We have canonicalized keywords, and we have ADRs. And then the last step is to ratify it. And it's when the last QA sync where we make sure that we're all set. So this is the QA gate, you can say. And then it will write the ADRs, write ubiquitous. Because from now on, since everything is immutable, we can't change it. And that's why we do that, is because the LLM should be sure of that I can read this path and I don't need to care anymore because it's immutable, all this data. So what's executing right now is the yellow. We split those into tasks. We split it on the DDD boundaries, hexagonal boundaries. So this is, we have a step for a human to say, okay, these tasks looks good. Have never adjusted them. So this will be the next flow that we skip, just automate it totally. Split up all these tasks. It's a DAG, so it's topology sorted, so we can make sure that the dependencies are executed in the right way, and we can parallelize it to make it a bit faster. It's also QA gated, and we know which agents that we have used, so we know which are the candidates for the QA reviews. And it has all the steps. We do arch linting to help it to stay on track, so it doesn't put something under ports and implementation, for example, where it should be on adapters and so on, and which trail it should go on. We do the testing, and we do TDD and everything else, and we slap on a QA review to do adversarial reviews. We switch models optionally, because other models are seeded differently. We use Claude often, Claude 4.8 right now, to implement stuff, and use GPT 5.5 to do the QA reviews. But we can do the reverse as well. The important part is that we use different models, because they are seeded differently. They will discover different things. They tend to look at their own thing that, oh, I'm great. I do nothing wrong. So yeah. The last one is the feature review, where we go over the whole feature scope, do all the integration testing, and make sure to do the review over the whole one. And here is also where we do security over adjacent systems as well. So we don't just focus on what we're doing right now. We have to see how does it look in a larger scope. If it detects that we need to implement more, it automatically adds new tasks, and the scheduler, in this case the feature implementer, will pick those up and continue implementing, because we want to get damn sure that it has tried as much as possible to implement this during the night, so we don't have everything stopped in 1 in the morning, and then we have all 4 hours or 5 hours to actually fix this. So yeah. And now the PR is ready and ready to be merged into main, hopefully. If not, we have to fix it, and we either do that using prompting, or we just fix it ourselves. Yeah. A working day. Oh yeah. So a working day is that wake up in the morning, look up all the PRs, see which are easy to review, and see, okay, merge. This has been blocked. It has figured out that, actually, we need to change the architecture. And that's definitely a user interaction, so it will be blocked in that sense. Otherwise, it sometimes hallucinates and thinks otherwise that it needs to be blocked. Just unblock it. This is in your imagination, or do this, and then continue, and it will continue to implement it. The afternoon is all about PRDs, features, and grilling, and do all the rest. And the night is implementing time. But the thing is, The
agent is implementing, right?
Yeah,
You're sleeping.
yeah. And of course, it does jobs on the daytime as well sometimes. But what we have changed, I used to type a lot of code. I maybe not the coolest programmer in the world, but I could easily spit out 1,000, 1,500 lines of code, no problemo. That was easy for me. Implement a lot of features. But nowadays, I don't implement too much. I fix stuff and so on. Now I do much more thinking, working as an architect and as a designer and design the product and let AI implement most of it. But since we are controlling sensitive and infrastructure, some parts we are very keen on continuing to develop ourselves, but this will lighten up and also implement those, because there are some hard parts that it's not easily to delegate. Security and compliance. Yeah, I told you. We do in both spec time and implementation time, we do security checks both on the feature itself, around the subsystem or the system, and then we are now going to go into, we are ISO 27000 XX NIS2 compatible. Yeah, I don't know if it's an EU thing, but we have lots of ISOs that we need to follow. And so there are processes and audits and everything. And we are writing an MCP and lots of skills and agents to conform to that, so we can automate many of those tasks, because they are tedious and they are hard. They're not very easy many times.
So, question. Remember the task you kicked off?
Yeah?
Was it all the steps that you just described?
Yes, it was.
I've been watching here while you've been talking, and it's been some drama. It's been really fun. So let's see what's going on in Shore.
Yeah. Oh, yeah.
Yeah, I know. I'm so happy.
That's nice. So we can see here that
it worked.
It worked. Yeah, shipped and approved. So that's nice, and it will tell you a bit what it did, and you can see that it did 2 rounds with 5 reviewers, and yeah, everything works out fine.
There was an adversarial reviewer at one point, and I was looking as you were talking, and I was like, I don't know what this means. I don't know if this is gonna stop, but it fought it. It won. It was like a video game. It was super fun.
Yeah, and it will output a PR that we can merge in here. And the good thing is also that we can go in to see the feature review and see what it has done and so on. So we can do that in the morning to make sure that we're doing it correct. Simple ones like this, we don't care. I mean, we just look at the code and see, yeah, it looks good. There's, no, sorry, pull request. We can merge it. So there's not much code because it's a new repository that we have implemented, an SQLite repository, so we can have persistence. And it seems to be documented properly and so on. And what we can do now, go back. I'm a bit nervous.
You shouldn't be, it worked.
Yeah. So we can merge the pull request then and confirm the merge.
Live merge, everybody. I think this deserves a hand of applause. Come on. You did it.
I did nothing.
That's the best part.
Yeah. So let's switch over.
Awesome. Well, thank you. I really enjoyed that. That was so much fun for me here. So folks, to recap, we're in that heady phase of this new technology. We just live merged. All this work happened while Mario was talking. It's so much fun. It's the same as has happened in decades prior, right? Think when you got the iPhone. Think when cloud computing was a thing. And there's lots of excitement. And then similar problems show up. As I was discussing in the beginning, vendor neutrality is really important if we're going to rely on this technology for all our important workflows. We need guarantees of data portability. If you're going to lock me out of your system, that's okay, but I need my stuff. FinOps, so fast. I think they're calling it AIOps. I don't know what the new name is, but we called it FinOps in the cloud native ecosystem. And the thing I really like is that we're already thinking about this in the generative AI tooling era. I think it took a little bit longer in the cloud computing era for people to wise up around it, but we're learning from our mistakes, standing on the shoulders of giants, all that good stuff. And then, of course, we spent a lot of time talking about the drift that compounds and compounds so fast when agents are at play. The one thing I'd like to call out is that the one difference is that these problems have a wider surface area now because everyone's a builder. I'm a builder, you're a builder, like it's the Oprah show. You get to build, you get to build, you get to build. It's a party. But that means, again, more of a surface area for problems to impact the business. I think, what are our future plans? This wasn't the end of what we are doing. This is the beginning. We want to stay nimble in our tooling and aggressively support open source and vendor neutral options wherever we find them. We're very excited, actually, with how Copilot is developing. We've seen some awesome demos. We've gotten the parallelization, Mario tells me, is just the best. So this is really nice to see. Mario will keep automating and building the software factory. And we'll always, at the same time, be evaluating build versus buy, open source, all those options, because you have to, as a business which wants to stay focused on our actual deliverables to our customers and not get into tool building mode. With that said, folks, this is a new era. It can be intimidating. It can be annoying. But at the end of the day, you've been given a brilliant colleague that's going to be always available to work with you, amplify you, and expand your impact. So why don't we just have a good time with it? Let's enjoy. Thank you so much. By the way, you can find me on all the platforms, LinkedIn, Twitter, GitHub, with my handle Priyanka. I know you can find Mario on GitHub with this handle, but he's not sure about the other ones.
Minus the dot.
Oh, whoops. Also, I really need your help to ship my website, so please follow us on LinkedIn. The minute I ship it, I'm going to update it there. So the more of you that like us there, the more pressure is on me, and I'd like that support very much. And you can give feedback and contribute to the Think Harness by emailing Mario.
Yeah.
Thanks once again. Have a great conference.
Yeah. Thank you.